All right, so let's consider question number 5. And the question reads, it is estimated that an investment in a new process will cause the following cash flow in the dollars. That is to say, in these given years, right? So you have the year here, let's have the year. You have the cash flow, you have the cash flow, you have the discounting factor, and you have the present value on the other hand. So this is what you have. Let's have this. You will be fine, don't worry. You will be very much fine. So what I have just done, I have just rewritten this, the format. This is horizontal. They are in rows. Now I make them in columns. So the year we have 0 year, first year, second year, third year, fourth, fifth, and the 6th year. Okay, these are the cash flows that we have. So the cash flows that we have in the second year, in year 0, we have 600, right? In the following year, we have 100, we have 150, 200, another 200, again 200, and 200, right? These are the cash flows. So we are told now the firm wishes to earn at least 15% per annum on a project. That is the amount that they want to get. So 15% of this shall be your discounting factor, shall be used to calculate your discounting factor, or the discounting rate shall be 15%. And so we need to find a discounting factor. We said to find a discounting factor, you just say 1 divided by what? 1 plus R to the power n. Do you remember something like this? If you went through the notes. You do remember, right? So the discounting at 15%. So where R is your what? R is basically your rate of return or discounting rate in decimals. So for the first one, where n is the number of years, that's what we said. So you can find the discounting factors. That's the first thing at 15%. So you can say 1 divided by 1 plus 0.15. Okay. When you do the addition, you find 1.15, isn't it? As the denominator, 1.15 raised to the power n, where this n is the number of years. So this n is 0 for year 0. This is the year when you invest your money. It's called your year 0. So what do you have? Can you compute 1 divided by 1.5 to the power 0? On your calculator, you can write like this: 1 divided by, you open the bracket, 1.15, you raise that to the power what? To the power 0. Okay, for a 0. What do you find? Just command your calculator like that. Hello. What are we finding?
For me, I'm using my phone, but I'm trying to do it using a calculator on Google. You said 1 divided by, open bracket.
1.1. 1.15.
1.
Someone can do for a 1 divided by 1.15 to the power 1. Then someone can do 1 divided to 1.1 to the power 2, just like that, through up to 6.
To the power what?
Like
0.
the n is the number of years. Yes, start from number 0 here, because we are starting from year 0.
It's 1.
It's the one.
The
Thank
power,
you. So
yes.
okay, so we have 1. That is our discounting factor. It is 1, right? Our discounting factor is 1 in year 0. What about in the subsequent year or in the other year?
Uh, 0.7.
That is for year 1, year 1,
Yes.
0 at 0.7. Let's hoping we are hoping that you're giving us to 4 decimal places. Give us to 4 decimal places.
0.66. 0.6666.
Okay, 0.6666.
I don't know. Somebody should confirm with me because I'm just using it. I'm using the calculator on Google.
Use anyone to use a normal calculator. You don't have calculators where you are? Okay. 1 divided by that, I find 0.870 in 3 decimal places. And then for year 2, I find 0.756, 0.658, and 0. What? 0.572, then 0.497, and 0.432. These are the discounting factors. The main thing was just to learn how to come up with them. That is how we come up with them. Is that clear? Okay.
Yes, it's clear.
So from here, what you do now is start multiplying cash flow times the discounting factor. Now, these in year 0, like the cash flow that you have in year 0 is a cash outflow. So it should bear a negative sign. So you will write your cash flow as negative what? Not like as negative 600. Put it in bracket. Okay. That is for a 1. When you say 600 times 1, yeah, it is negative because it is in year 0. Okay. In the year when you're making the investment, the cash is moving outside your hand. Okay. What is 100 times this other one? 0.870. Find 87, right? Should be 87. What about the other one? We can move faster if you have calculators where you are. And like when you have not the calculators. What about the next one in year 2? 150 times 0.756. Okay. 113.4, 131.6, 114 point what? 0.4, and the 99.4 and 86.4. These are the figures that I find. So from there, this is what to do. Just as we did it last time, I said these ones which are positive, you should add them together and then subtract a 600, the one which is negative. Add these from their sum, subtract 600, the negative one, or the cash outflow. What you have is the NPV value that is positive. It is 32.2. It's positive NPV. Is that clear?
Clear, sir.
Hello, am I logged out?
It's clear.
Hello?
Hello?
Yes,
Hello?
please. Yes, madam. I'm asking, is there any question from anyone?
Not on my side.
Madam Ndanji, do you have any question, madam?
No, I don't.
Okay, great. Then if there is no question, we have found the first NPV, right? The first NPV is 32.2. It is positive at 15 what? 15%. Now, just as we said that in that formula, we also need the negative net present value. Okay, so that is done by doing the following. We said if the first value that you found is positive, right? The first NPV you found is positive. So you need a negative one. So to find a negative, what you do, you raise the what? The discount rate, isn't it? You should add at least two steps. Start by adding 2 steps and try what net present value will have. So when you add the 2 steps upward, that is what will happen is that as you increase the discounting rate, the net present value reduces. So therefore, the net present value from positive it is going to become a negative. Okay. So add from 15%, it is going to be at 17%. Let's leave it at 17 and try if we have a negative NPV at 17. Okay. Let's find the discounting factors at 17% now, which is 0. It should be 1 divided by what? 1.17. Let's start with to the power 0. Obviously, to the power 0, it will give us 1, right? Yeah. What about the second one? It's always nice when you are participating because these things, I already know them. You have to work to participate as well. That's when you can learn. What do you find when you put power 1?
So
You
it's
say 1 divided by 1.17 raised to power 1.
Okay.
3 decimal places. Okay. 0.855. Then this one is 0.731. To the power, when you raise it to the power 3, it will give you 0.64. When you raise it to the power 4, you will find the 624. You find the 0.534. Raising it to the power 5, raising this number now to the power 5, what you get is 0.456. Okay. And the last one, you raise it to the power 6, it shall be 0.390. That is if this becomes power 6. Okay? All right. That is how we find the discounting factors. Do I have a question on how to find the discounting factors? I said you need 2 present values last time for you to find the, oh, you have already found the present value, right? The first one. So I've answered the first question. That was saying, find the net present value of the project. You got it, right? We found the net present value was 32.2. Did you get that one?
No, sir. Maybe I was behind on that one. 32.2.
Okay. We had worked out at 15% the way how we are doing it right now. That's what we had done. Then we found the 2.2. Let me just proceed for 17, then you get it. So for this one, you multiply 600 times 1, it will give us negative what? 600, okay? It's negative because it's cash outflow. 100 times 0.85, it shall be 85.5. You're following the way how I'm multiplying, right? 150 times, what is 150 times 0.31? Oh, 0.731. You get 109.65. Okay. Then 200 times 0.624, you get 124.8. And you get 106 here, 0.8, and 90. You also get 91.2, then 78 when you say 200 and 0.390. These are the cash flows that you get, right? Then I said last time, you can you have to add these for you to find the net present value. Add these which are positive, then from their answer subtract 600. You get, ka? You can add all of them, then subtract 600. Should be able to get negative 4.05. You get it, right? So this is at 17%, but when you did it at first at 15%, the same process, but what happened the discounting factors were different, you saw. The net present value we found, it was 32.2. It was positive. That is the answer for A. Because the first question says, calculate the net present value, NPV, for the project. So I'm calculating the net present value. So the net present value was found as 32.2. Is that clear?
Yes, sir.
Okay. Then question B says, question 5IB says, the IRR of the project. Now, for you to find the IRR of the project, I said you need 2 present values. The other one should be positive. The other one should be what? Negative, right? So you have 2 discounting rates. The other one that gives you positive, and the discounting rate that gives you a negative NPV. Those are the things that you need. So we did say that, at least now, since we have gotten these figures, we have negative 4.05 and 32.2, then I can erase this. The formula for IRR, internal rate of return, we said it is equal to A plus what? The small a over the small what? Small a plus small b multiplied by what? Capital B minus A. Okay, percent. So what is capital A? Very important to define that. The capital A is the lower rate of return which with positive NPV. The lower what? Rate of return with a positive NPV. Then capital B, it is the higher rate of return. Higher rate of return with negative NPV. Is that clear? Is the rate of return the discounting rate, those we had? The other one that gave us the negative was 17, right? Here we found 17. Then for A, the lower rate of return, it was 15%. That's the one that gave us a negative NPV. Then you also need the small a. What is a small a? So the small a is the amount of positive NPV. So it is basically the amount of positive NPV. NPV simply stands for net present value. Then the small b, get this one? It is an absolute value or amount of negative NPV. But make sure that that negative NPV, when you're writing here on this B, you write positive. That's why we're using the word absolute. Is that clear now?
Yes, sir.
Hello?
Hello?
You can always ask questions. You can always ask questions. On A, the amount of positive NPV, what did we say it was? What was the value of the positive NPV? Okay. So I said that it was 32.2, and for negative NPV, we found a negative 4.05, right? That's what we just found previously. Yes, so this is what is there. So we can substitute these values into the formula, right? Can easily substitute the values into that formula that we have above. We have known what they are, so I can erase now. Okay, so that we solve. Okay, that will solve the net present value. Expect such in an exam or in a test. A is 15. 15 plus, what is our value of small a? It is 32.2 divided by, what is the value of, what's the value of small a again? 32.2 plus 4.05. Okay. Then he multiplied by 17 minus 15. Then you have percent. Did you get that one?
Yes.
Okay. So we have 15 plus, let's add here. So when you do 32.2 divided by 32 plus 405, what you should get is 0.888 multiplied by 17 minus 15 is 2. Multiplied by 2. When you multiply 0.88 times 2, it gives us 1.776%. Add everything, 15 plus 1.77%. That should give us what? IRR equal to 16.776%. Okay. that if you want, you can still round it off to 17%. Is that clear?
Yes, sir.
That is our internal rate of return. Now, the question says, continues, it says, hence otherwise, comment on the course of action to be taken. Should they invest in this project or not? Let's use first then the present value method. That first one where we found the 32% or 32.2, the net present value equal to positive 32.2. Using that ruling, should they invest or not?
They should
What do you,
invest.
okay, why do you say so?
Looking at what we found, 32.2, which would be good.
Okay, thank you very much. So as long as the net present value is positive, okay, when you're using the net present value approach, as long as the net present value found is positive, you can go ahead. It means that the project gives more return than what you invested. Then if you find a negative, it means that what you invested is actually more than what you receive from the project. And if you find a net present value equal to 0, it means that you get exactly what you invested in the project. So now, using the IRR, the internal rate of return project, how do you, the internal rate of return, how do you rule? Or what's your conclusion? Should we go for the project or not? Anyone can answer. Using the internal rate of return, we have found that it is 16.776%. What is going to be our goal ahead? Is it, are we going to invest or not using the IRR approach? All right. So you have to pay attention to the way how these decision rules work. Okay. What is the decision rule? So the decision rule says, as long as the internal rate of return is higher than the target according to this project is 15%, isn't it? They are saying that the firm wishes to earn at least 15%. So as long as this internal rate of return is higher than the expected, we can invest in the project, okay? But if the internal rate of return is less than the target, then we cannot invest in the what? In the project. Because it will mean that we will spend more money than what we are going to receive. Similarly, if you find the IRR is exactly equal to this target rate, it means that we get exactly what we invested. Okay, I repeat, if the IRR is greater than the target rate, then we can invest in the project. If it is less, we do not invest in the project because we're going to lose our money. It means we are going to invest more than what we are going to receive. But again, if these two values are equal, it means we receive exactly what we invested in the project. Okay?
Okay.
Any question from anyone? Mr. Ngandu, do you have any questions, sir?
No, sir. Everything is clear.